Hello friends, myself Kunal Sir. Welcome to Private Education. Here I am with one again video, so that's a video number 5, by discussing the elliptically polarized light. As you know, this is a short video series for the JAM candidate, for the NET candidate. Okay, so in this league, I am here to discuss the elliptically polarized light with you. In our last video, we have discussed the circularly polarized light. So in a similar way, I'm going to discuss today the elliptically polarized light. Okay. So if you see our video number 2, I told you, let's suppose I'm writing the electric field equation, that is A cos kz minus omega t I cap plus B cos kz minus omega t plus phi j cap. Okay. So I have written a general equation for the electric field. If I write here the x component of the electric field, that is the Ex vector, and this is given as A cos kz minus omega t, that is in I cap, and the Ey vector will be B cos kz minus omega t plus phi j cap. Okay, where phi is the basically phase difference between the two components of the electric field, that is basically in the direction of the x and in the direction of the y. Okay, I'm not going to derive once again. We have derived this relation. While now what we are going to do, basically eliminating the time factor from these two equations, we are going to find out the equation of path. Okay, as I said, I'm not going to basically derive that particular equation because we have derived already. So I'm going to write that directly here. The equation, the master equation, the final equation which we will get, and this equation basically given as Ex square over A square plus Ey square over B square minus 2Ex Ey cos phi over AB, and this should be is equal to sine square phi. So the question is how basically we have got this expression. I am telling you, just eliminate the time factor from those two particular equations, electric field in the x component and the electric field in the y component. Just eliminate the time factor and find the equation of trajectory or the equation of the path. You will get this particular equation. Now, what further? Here now, superimposing the condition on the phase difference as well as on the amplitude, basically, we got some different types of polarized light. Like in the video number 2, we have seen that if I put the value of pi, there is a phase difference, that is a 0 degree or n pi. Okay, we were getting the plane polarized light. In the last video, I told you if the amplitude is same, that is A and P, if this amplitude is same, and we are putting the phi is pi by 2, that is a 90 degree, we are getting the basically circularly polarized light. And in this case, if A is equal to B and also the phi is pi by 2, if I'm doing this, okay, if A is equal to B and pi is equal to pi by 2, we will see that we will get a circularly polarized light. But in a similar way, if I put just one condition, that is A is not equal to B. If A is not equal to B but the phi is pi by 2, let's see what we will get. Okay, so I'm writing here, just look at here. So if A is not equal to B, that means Ex is square over A square plus Ey square over B square. Put the phi is pi by 2, then the cos 90 will become 0 and sin 90 become 1. That means we will get this particular equation. This equation basically signifies which trajectory? It's an ellipse, right? So what's the case? The case is if amplitude, that is A and B, are not equal and the phase difference between the two components of the field is pi by 2, the resultant light ray will be elliptically polarized light. Okay, the resultant will be the elliptically polarized light, and basically it will project, it will be projected something like this. Something like this. Okay, something like this, not exactly ellipse, but basically I'm telling you, you can find out the you can draw the ellipse like this. Okay, this is a Ex, this is a Ey. Okay, but the question arises, okay, we have seen if the phase difference is phi, if the phase difference basically is 0 or n pi or pi by 2, we have superimposed the condition on the amplitude also. But the question arises, we have seen for the 0 degree, we have seen for the n pi, we have seen for the pi by 2 or the integral multiple of the pi by 2. But what will happen if the phase difference is neither 90 degree, neither 0 degree, neither 180 degree or some random angle? Let's suppose the pi by 4. Then what will happen? Which type of trajectory is going to be formed? So guys, if you want, you can basically draw by using the MATLAB or the Python. I'm telling you, if the amplitude are not equal and you are taking any random angle like the 30 degree, 45 degree, 60 degree, 70 degree or any random angle, you will get a trajectory as the ellipse. I'm not saying it will be a regular ellipse, but yes, it will be ellipse. It's some regular, it can be some irregular ellipse, some right ellipse or the some left ellipse maybe, but overall it will be an elliptically polarized light, that's for sure. Okay, so if you are changing the phi, if you are changing basically taking the phi equals to pi by 4 and the amplitudes are not equal or any random angle, not only the pi by 4, pi by 3, pi by 6, whatever, still you will get a elliptically polarized light. Okay, so the main funda is this particular equation, this general equation. Guys, if you know this equation, then by putting the value of the phi and by changing the amplitude, basically by just analyzing the trajectory equation of the particle, you can say, okay, this is basically the trajectory of this light ray, and hence the emergent light ray, the resultant light ray will be plane polarized or circular or elliptically polarized light. Okay, so I hope this video finds you good and it's quite informative for the as far as the JAM candidate or the NET candidate. So the types of the polarization has been over here. Okay, in our next video, basically I will come up with the Malus law and I will tell you how the production of the polarized light is going to be held. Okay, what is the Malus law and what are the condition and what is basic funda behind the Malus law. It's a very important as far as the NET exam, JEST exam, JAM exam is concerned. If this is the physics paper, you can on a very frequent years you can get the question from the Malus law. Okay, so it's a quite important. So very soon we'll meet in the next video. Thank you so much.